This problem is a problem where the object is projected horizontally off a table, off a cliff, thrown straight out, whatever. But the horizontal speed given in this problem is a ball rolling at 2.3 meters per second off a bench with a height of 1.35 meters. So if I just think of a picture of this, here is my bench, and when I project this ball off the table, all of the velocity is in the x direction. Velocity in x is 2.3 meters per second. Okay? And then the height of the bench is 1.35 meters. We need to find the time it takes to hit the water, the distance away, or the distance in x. We are also going to find the vertical velocity of the ball when it hits the floor. So the instant it hits the floor, what's the velocity in y? And then the resultant, or the actual velocity it hits the floor with, because it's not hitting the floor straight down, it still has the forward velocity of 2.3 because the velocity in the x does not change because there is no acceleration in the x. So in the end, I'm going to find this velocity that's hitting the ground with. So first step is to gather all of my data or organize all of my variables. I know the velocity in x is 2.3 meters per second. I know the velocity in y initial is 0 because the object is projected horizontally. I know the displacement in y is going to drop 1.35 meters, so that's negative. I also know acceleration in the y is negative 9.81 meters per second squared. I am supposed to find the time, which does not have dimension. I'm supposed to find the displacement in x, also no dimension, the final velocity in y, and then the resultant velocity. So I make a mental note that the only equation I can use in the x dimension is velocity equals distance divided by time. The reason for this is because the x dimension does not have acceleration. I don't have enough information right now to use that equation because I don't have time and I don't have displacement in x. So I'm going to have to focus on the y dimension first, and then I can go back and solve for the x. So doing the questions in order, the time it takes to hit the water, I'm going to look at the y dimension and the variables I have, and I need to find time. So I need an equation that has acceleration because the y dimension has acceleration, and I need an equation that will allow me to solve for time. So the equation that works best when I look through all of the equations is this one. Now all of the variables that are being used in this equation must be in the y dimension. The acceleration, the initial velocity, all have to be in the y. So when I put in my numbers, negative 1.35, 1/2, negative 9.81, time squared plus 0, because my initial velocity in the y is 0, making this whole factor 0. And when I solve for time, I get 0.5246 seconds. Okay, I can round that to the correct sig figs if that's my answer. I can put that up here. I need 2 sig figs, so 0.52 seconds. But when I take that number and use it in a further part of the question, I do not want to use the rounded. Okay, the second question, or B, is to find the distance away from the base. That's the distance in x. So the only equation I can use is the one without acceleration. So I know my velocity is 2.3. I know my time from the previous part is 0.5246, and I can solve for displacement in x. When I get that number, it is 1.206 meters. And at any point in this video, you can pause and try to calculate it on your own and see. The third question is the vertical velocity in the y direction. What is the velocity it hits the ground with? It is not 0. We are looking at the instant it hits, and it has a velocity when it hits the ground. In order to find that, I have more variables now. I have time now that it hits the ground, 0.5246. I have displacement in x now, but that doesn't help me because I'm looking at the y dimension. But with that time, I am able to use an equation to solve for the final velocity. I know acceleration is negative 9.81. the final velocity I'm looking for. The initial is 0, divided by the time, and make sure it's not the rounded time, 0.5246. When I solve for final velocity, I get a negative number, which makes perfect sense because it's falling, and I get negative 5.146 meters per second. With sig figs, that answer would be negative 5.1 meters per second. The previous question, letter B, the displacement would be 1.2 meters with sig figs. And then the last question is, what is the resultant velocity? What is the actual velocity that the ball is hitting the ground with? Okay, some amount of that velocity is in the x forward, some of that velocity is in the y down, but we can get this resultant by knowing the Pythagorean theorem. And so it's 2.3, your y is 5.146 meters per second. So when I use my Pythagorean theorem, it's going to be 5.146 squared plus 2.3 squared. And when I square root that whole thing, I will get the resultant, which should be 5.637 approximately. And when I round that, it's 5.6 meters per second is the velocity it hits the ground with. However, I'm not quite done because it's asking for velocity, and I need to have a direction to show that velocity. So I'm going to use this angle right here with the horizontal, and if I do that, I'm going to take tangent of the angle is the opposite, or the 5.146, over the adjacent 2.3. When I put that into my calculator, I'm going to divide 5.146 divided by the 2.3, and then I'll take the inverse tangent, or second tan on my calculator, of that answer, and I get an angle of 65.9, which with 2 sig figs will round to 66 degrees below horizontal. You could also do the angle with the vertical, just describe it correctly. So my final answer, 5.6 meters per second, 66 degrees below horizontal. There you go.